Good morning, Warsaw. Thank you for having me this morning here on this beautiful, well, not so sunny day in Warsaw, on the open source day here. I wanted to spend the next 20 minutes talking about something we call the second wave of open source, riding the second wave. As the introducer already said, I work for a company called EnterpriseDB. We have a beautiful stand here. EnterpriseDB is, and I've seen a lot of these beautiful red hats this morning already. EnterpriseDB is to Postgres what Red Hat is to Linux. So I just wanted to talk a little bit about what that database and what the technology can do for you. My personal background, I've been doing database technology for the last 25 years, and I've done a lot of other things as well. I've been involved in this other database technology, which is not per se open source, but this big red company out of Redwood Shores. Luckily, I've left that all behind me and saw the light and went to open source. Talking about these waves, open source, I looked it up, started way back. The very first wave of open source basically was actually the moment when software and hardware got separated. So when people started developing independent software from computer systems, actually the Share program was already launched. That was back in 1955 already, and that was basically the very first start of this first wave of open source. After that, Digital Equipment Corporation, anybody know DEC Alphas? They started with a program called DECUS, and DECUS was already also into distributing software freely, where free not really stands for it doesn't cost anything, but free stands for freedom, freedom to use software. GNU and Linux came after that, and this kind of made this first wave of open source running through the software realm that we know today. What we saw when this first wave of open source came is that a lot of the software that was distributed here was basically easy to replace software. So a text editor, you would be using one text editor today, and if it didn't really suit your needs, you could easily swap it out because you just take another editor and start working on your document again. Or it would be utilities. A utility, you could use one utility today, another one the next day. Even operating systems are fairly easy to exchange. If you're using one operating system today, you can just reinstall your programs and move fairly easy from one operating system to the other. This kind of illustrates this first adoption of the industry towards open source technology. There has been a relative pause, beginning of 2010 up to a couple of years ago, where there was kind of stability. Obviously, the development of other systems kept on going, but the first things we saw was that databases were coming, like NoSQL databases and these kinds of technologies which were adding to a scale of software employments within companies. Still a little bit of the first wave, easy to replace, it's additional to your business, but what we've seen over the last few years is that more of these core complex systems are being adopted by open source. So companies are now really going into, this is not easy to do. If I have a relational database where my complete infrastructure, where my core business is running on, I need to replace it. I want to replace that by something else. It is not something you do overnight. It takes a little bit of thought, and it has a lot of risk. If you're running your core infrastructure, if you're running your core business on this infrastructure, you're going to change it, it will get risk to your business. This is what is happening in the second wave of open source. And if these two waves come together, you get something, if you're on the beach, where the surf is right, this surf happening where first wave and second wave are starting to come together. This is what we see where we look at replaceable technologies starting to support the implementation of these more complex systems. DevOps, I think, is a very beautiful example of this, where we get all these cool utility-like software tooling like Ansible, Puppet, which are freely available if you take the regular versions, which you can then start using to deploy more of these complex systems. Make sense? Inside application development, we also see a paradigm shift. Traditionally, people would develop software in a waterfall sense, like I'm going to build something, I'm going to test something, I'm going to put it on stage, and then I'm going to take it in production. Regular waterfall development. What we've seen today is that more and more software needs to be built quickly. It needs to be agile. Agile is one of these cool buzzword bingo words, right? Everything needs to be agile, everything needs to be quick and flexible. The applications get broken down in smaller parts, so you don't have these big teams building monolithic solutions anymore, but it's very granular. And one thing we see is that relational database technology is not dead. In today's world, one of the things we see is that the amount of data which has been stored, and I had the discussion this morning already with somebody who came up to me, we want to include 60,000 servers to start writing data to my database. So the amount of data which is being captured in the world is still growing. It's growing, exploding. On the other hand, we see all these new database technologies coming up with NoSQL databases, with Mongo, with Cassandra, with all these Hadoop implementations where there is a lot of data being captured, being stored worldwide. And one of the other things is that we see in the core, to be able to actually start using and reusing the information which is being captured and stored, we need relational database technology. This is one of the reasons why, for instance, Mongo is now starting to implement relational technology in front of their solutions. What we can derive from that is that even though it doesn't look like much, the relational database technology and the relational database footprint is still increasing today, and it's getting more and more importance. So for that, SQL will never die. It is the way to kind of mine and reuse and find information in all the data that we're storing. Luckily, we have Postgres. And even though it's over 30 years old, it's still very much forward-looking. So if we look at Michael Stonebreaker, the guy that actually created Postgres, his vision was to create a expandable relational database technology. To have a relational engine where you can build new functionalities, where you can build new functions, new technologies around, which still work like they were created with Postgres. That is today as if it was built for tomorrow's challenges. And I think that's a very important differentiator in this relational database technology space. If we look at DevOps, a lot of companies are struggling. A lot of companies which employ the big red, for instance, they need to start doing agile technology because paradigm shift, what we saw from waterfall to agile development dictates it. They are struggling very much with getting this database installed, getting it provisioned to their users quick enough. So there is a big challenge there. And it's of strategic importance to be able to kind of answer this challenge, right? If you then look at Postgres, if you look at how it fits in the second wave of Postgres, if you look at how it fits in this surf that we saw, where these waves come together, Postgres was basically built to fit in here. The small core footprint that it has and all the abilities to work together with these infrastructure as a code technologies makes it more or less fit naturally. Application development. If you look at today, I was talking to a company a year ago, I think. They were building an online application. They had teams which were responsible very small parts within this application. So there was a team responsible for a specific button in the application. That also means that if the application gets smaller and the teams that work these specific functions get smaller, you get up with a very complex system for actually developing applications. It was also an application which was online available, and they were able to update a specific part of the application during the runtime, because they were able to say, well, this button, for instance, is not that important. I'm going to update this at a specific time point. And by that, they were able to deliver new functionality to that application while everybody was actually using it. This requires a level of technology that open source combined with fitting technologies like, for instance, Postgres can bring you. And again, integration, so this needs to continuously work. It's not just about building in these kind of small granules, but you also have to be able to deliver these granules online all the time. So this is where continuous integration, continuous delivery, and technologies like open source, like Postgres, this all integrated together bring big advantages to the business today. To take this to the next level, we've got containerization. Everybody played with containers so far? A couple of people? What we see today is that containers are coming. One of the things about containers is they are designed for stateless workloads. That means if you've got an application that doesn't store data or that is just being built and being delivered, that works perfectly. The challenge is that obviously a database is not a stateless application, because if I store something in my database and my container crashes, what they were actually kind of designed for, then my record would be gone, which is not a very good idea. So this is something that Enterprise DB with our customers are working on today to get fixed. To be able to get this next level of granularity and this next level of agility in the organization together with using relational databases like Postgres. I was at a keynote, I think 2 years ago, a guy called Edson Yanaga, and he had a very interesting discussion, and I was able to kind of link that to containerization. He said, I was working for a company and I was actually building an application, and we all know this, right? It is the day that we're going to put the application in production. It's Saturday, and we've planned to go live at 4 o'clock in the afternoon, and at 4 o'clock in the afternoon, everything was lined up, and he pressed the button. The application went live, and obviously nothing worked, because that's mostly how it goes. So they were toying on this, and it got to be Saturday very late, and at some point, the CEO of the company called. Mr. Yagana, what are you doing? And he answered, when I built the application, it worked on my computer. And the cool thing is, well, the CEO said, that's cool, but I'm not paying you to make it work on your computer. I am paying you to work it on my computer. This is also where containers come in. If I build something, and I build it in a container, and I am able to kind of get it running, I can just take that one container and move it to the next stage. Move it from development to testing, move it from testing to staging, and move it from staging to production. Basically the same functionality and guaranteed that it will work that way. Build once, run everywhere. The same technology is available using these containers, and you can even put it in the clouds. Well, we've got a lot of clouds out there today, so that's also something that's going to work nice, right? Moving forward, looking more and more forward with Postgres, one of the things that is now coming is pluggable storage. We have a lot of specific purpose databases out there, columnar databases, analytical databases, in-memory databases, database working on specific storage technologies. This is what Postgres, the Postgres community recognized. And what they're now doing is building a technology that allows you to take the same relational database engine that your application has been used to, that you've been building, that you're comfortable with, and actually give you the opportunity to unplug the storage engine, unplug the traditional storage engine, and introduce new technologies. This is, in this space of relational databases, something which is fairly unheard of. Using that same extensibility system that Michael Stonebreaker envisioned 30 years ago, we are now able to exchange storage engines in a relational database. This opens up a lot of new possibilities where we can start using Postgres in analytical, in mass storage, in in-memory capabilities, things that we've never envisioned possible before. And the final thing, I think, for this morning to share with you is something which is called sharding. In relational databases, writing, mass writing, has always been a problem. So if we want to do a query or an update, one of the fundamentals of relational databases is that it is an ACID compliant transaction, meaning that it's going to be secured, it's going to be safe, that it's unalterable. That also meant writing and transacting and processing data over multiple nodes was always a very big problem. CAP theorem is one of the technologies and one of the academic theories that plays in this area. With Postgres, we will be able to push the boundaries of the CAP theorem within a couple of years by introducing sharing for transactional databases. That means we are going to get multiple Postgres nodes which all have a shard, a part of data, and they will be able to transact and process one atomic transaction over all of these nodes. That is one of the coolest things coming to Postgres to a place near you soon. With that, I think I'm more or less through my time for this morning. Enterprise DB, again, is one of the companies driving all of these technologies, driving all of these changes. We're having a stand here together with Linux Polska, and I hope to meet you here today. I will be here today for the rest of the day. So please come visit us at our booth. And with that, I would like to thank you.